the situation where you have a target and you'd like to find a qualifier, and you have a chlorinated compound or a brominated compound. And what that allows you to do, because chlorine is showing a ratio in natural abundance in the 35 to 37 ratio of, let's say, a third, and the bromine 79 to 81 at about equal abundances, you can pick another transition that does not have the same precursor ion and use that to find another qualifier, and even more, add the abundances of those to become a quantitated amount for the entire compound. And let me show you them. Are in the method editor, and I'd like to zero in on cocaine as the target compound. So here we have the expected. In other words, the precursor ion of 304 is the same as the precursor ion for the qualifier. I've just picked different product ions. In this case, 182, and in this case, 82. And you can see that from below in the overlay of the qualifier ratio. I see the transitions 304 to 182 and the qualifier 304 to 82. What I'm going to show you here is not exactly what I mentioned with a chlorinated compound, but I'm going to show you the same issue laid out here with the heavy cocaine deuterated compound, which has a transition of 307 to 185. And I've changed the method here so there is no ISTD relationship, so I can validate this method. And I've created a new compound that I'm going to call cocaine light and heavy. So the original target transition that I had, 304 to 182, still exists. And now I have added the heavy ISTD qualifier, 307 to 185, as the qualifier. Obviously, the qualifier ratio is going to be completely different, but let's keep focused on the fact that I can add a qualifier with a precursor ion that's different than the target transition. And if you notice here, when I go down to this, that you'll see the qualifier overlay is 304 to 182 and 307, the heavier target compound, the deuterated, to this transition. So let's go and quantitate that and see the results. And what you'll see is, because the target is the same, we're going to get the same quantitated results. So here are exactly the same quantitated results for the heavy, light and heavy, giving me exactly the final concentrations as the cocaine results. Now finally, let me show you the ability to area sum. So in the cocaine light heavy, where I have a transition for the qualifier that has a different precursor ion, I'm going to area sum. So watch happens when I do that. Notice that the quantifier transition changes from 304 to 182, 185, meaning it's going to sum both the target transition as well as the qualifier transition. So let's go over and think, what would happen when I quantitate now with that particular kind of method? Well, it's going to add in the qualifier, which is the heavier. So if I look at these concentrations here, the original concentrations have been bumped up by pretty much of a constant factor. And that constant factor is the heavier ISTD transition that I've added in as the qualifier, and then that final concentration for the cocaine light and heavy has been bumped up and notched up. And you can see that again. Here I've got the quantifier transition, which includes that qualifier. So let me leave you with the original goal. The goal is, I've got a target compound, and it's got a chlorinated analog say chlorine 35, and I want to add in the chlorine 37 as a qualifier, and potentially add that in to group those two signals together and sum those so that I would get a quantitative amount that included both the transition of the chlorine 35 as well as the chlorine 37 to give me one amount. This ability here to use a different precursor ion for the qualifier transition allows me to do that. Hope you enjoyed it.